Thank you. Well, I hope I don't duplicate too much what Bhushan just said. So my name is Daniel Kranowski, and I'm a software engineer with about 20 years of experience in development, test, DevOps, and some project management. And I'm here to talk about cybersecurity for companies that build, web-enabled software applications. And I talk about it as security as the new non-functional requirement. What I'm really trying to get across is just software teams, agile teams, treating security in maybe a little bit more of a formal way than we have before. So I'd like to talk a little bit about the tools and strategies that companies are currently using for security, what they should be using, and think a little bit about the company level perspective that can help or hurt your efforts. All right, check it out. So let's imagine that we're all in one big agile team, and this is our backlog. So we have stories, and what's a story? It's a functional requirement. It describes a piece of business value, and it tells you what you need to click in your app to get it. In contrast, a non-functional requirement is a cross-cutting constraint that affects all the stories. And good NFR should be specific. It should be quantitative. I put some up here you should know, like we've seen NFRs for performance and reliability. A performance NFR might be when we're on the product search page, we should get a result back in under 300 milliseconds. Reliability, an NFR might be this website needs to have 4 nines of uptime. That one's a little harder to verify. But then what would a good NFR be for security? So here's one that you might have heard of before. It goes like this. If your app has some kind of an error, don't send the stack trace up to the user. Don't let them see that, right? And this is a good non-functional requirement because it prevents, well, first of all, it's specific. It's something that you can verify. And it also prevents the hackers out there from learning a lot about the inside of your app, from seeing all the different names of the functions that your code was going through. So another NFR that we could use is actually kind of in the same vein, is don't expose the identity of your tech stack. Don't let, let's say that you're using MongoDB. You don't necessarily want the hackers in the world to know that because then it just makes their job easier if they're trying to get in and expose your data. If the string MongoDB is out there, just please filter it out before it gets to the front end. And so that is, again, it's specific as an NFR. It's also something that QA can verify. So it's useful that way. Now, in my experience, maybe this is just the kind of places that I've worked before, I just seem to find that agile teams don't talk a lot about security, yet we hear about it all the time. So there are people at your company who are talking about security. So who are these people if they're not coming to your stand-up? Okay, so operations, that's where it's at. When a company first gets serious about cybersecurity, they start with operations. And the reason, maybe because of how it's marketed, is because, well, the way they sell it is that operations security is easy. You just buy a tool. You buy the tool, you get security. It's very easy for people to follow. And of course, there are many useful tools. We don't just want to ignore the tools. You need the tools. There's the firewalls, the antivirus, email filters. There are newer tools that are coming out that are dealing with the more complex threats like security, info, and event management. There's unified threat management. Really, there's no slide large enough to cover all the different categories of tools that are out there. This is a screenshot, which is far too small for anyone to read, of Cisco ASA. This one is it's a hardware appliance. It's very popular. I guess we like to think of it as a classic because it's 15 years old. And when it first started, it was just a firewall, pretty much. And over time, it got more complicated. It adds new features like intrusion prevention, deep packet inspection. It's got thousands of built-in rules. You know, it's pretty good. And but on the other hand, you have to be really well trained to use a tool like this and to use it properly. I mean, you can buy the tools, and if it's not configured right, then you just wasted a lot of money. And you know, there's also the maintenance aspect of it, because you know, it's got 5,000 rules now. There will be 1,000 more by the time the year is over, because we're constantly discovering new things that need protection. So you need to have people on it. You need headcount. And not only that, to get company-specific rules that are like specific to your infrastructure, then you have to have the operations people communicating with the apps teams. And I think I heard something about communication. That's not always easy to do. And so it's definitely not a silver bullet, but you can't live without it. You need some kinds of tools, and that's like the strategy that we have at the ops level. Okay, so let's jump out and think about the applications level. So I'm more of an applications person, and OWASP is a good place to start. Just curious, raise your hand if you have heard of OWASP. All right, good. Hopefully in 5 minutes, we'll all be raising our hands. So OWASP is, it's a huge organization. It stands for the Open Web App Security Project. And they publish this top 10 list of like what they consider to be the 10 most important web security risks that you can run into. And it's a great baseline. It's really good. And I think that pretty much everybody who is in the software biz should get in and read these and learn about them. And so I'm not going to go through this in excruciating detail. I'll mention a couple, just two. Like at the top, injection. I think pretty much everybody has heard of SQL injection, and that's where you try and stick a badly formatted SQL query at the end of some innocent web form, and then it gets into the database, and bam, you have access. And there's also injection where you're injecting shell commands, and you're trying to get into the operating system. And so yeah, injection's bad. And how do you protect against it? The way that you protect against injection is you sanitize the user inputs. So you learn about this one. The answer is pretty much you sanitize the inputs. And so when you're looking at new code that's coming down that needs to be tested, try and throw something in there. Learn to be a bit more like a hacker. Try and throw in one of these things and see if you can sneak some injection in there. And being the bad guy inside the company is obviously a lot better than having us find out when somebody outside the company did it. I'd like to jump down to number 9, also components with known vulnerabilities. This one is really big because in open source, our projects, they depend on tons of other components. And when the security flaws are out there, it's great because it's open source. Everyone tells you where it is. But the bad side is everyone tells you where it is. And so we're in a big race. Every time a new flaw is announced, we got to rush. We got to patch it and before it's exploited. And it's a lot of time and effort on the engineering team. And that's a big reason why it never gets done. So anyway, we were in the weeds there a little bit. I'm going to jump back out and see if I can think about the strategy. Because security is so big and so complicated, it's hard to really get anything done unless you can stand at a bit of a higher level and come up with a strategy, something simple. So with operations, the strategy was tools. And with applications, it's engineering. And unfortunately, that is more labor intensive. So here are some suggestions I would like to make for people that are trying to do applications level security testing. These are all strategies you can follow. First one, architecture. Whenever you're dealing with engineering, architecture always comes first. A good architect should pretty much point out to everybody where the high-value digital assets are and give you a basic sense of how you should protect them. And there are many ways they can do that, like with tech stack. They could say, here, this needs to be encrypted, or this is how we should deal with authentication. And they can also deal with things that are structural design that are really specific to your company. Like they'll say this data is really key, keep it on the core machines. I don't want to see this data ever travel out to an edge node. That's something where an architect can provide guidance, and that's a big part of application level strategy. Next is some kind of vulnerability response. What's your policy going to be? And we were just talking about this. It was OWASP risk number 9. And really, if you don't come in with a plan, it's just going to be chaos. You need to have policy that says, here's how we're going to track the public vulnerabilities. And then when they come in, here's what we expect out of the engineering team. This is what we expect them to do. And also, you need to be pretty clear, these are the conditions under which we can preempt what everybody was already working on. This is when we decide a security thing is that important. And you just need to be organized about it. And the third one, agility, this is just basics of running a software organization. And like my example that I like to give when I'm saying why, how agility comes into it is, sorry about that. The example that I like to give is with, sorry guys, my brain just turned off. I guess the agility thing, okay, all right, I know, the two things that I hate the most, okay, so legacy code. Raise your hand if you like legacy code. Yeah, right. So I view legacy code as, it causes so many problems. And one of the, I think that people would maybe take it a little more seriously if they see it as a security threat. And the same for like overly bureaucratic processes, and it's real risk of getting a lot of extra bureaucracy when you start talking about security. You can scare people into bureaucracy. You don't want to do that. If your release process is overly bureaucratic, it causes people trouble and it makes you less agile. And that is, it should be seen as a security risk. So really, in my opinion, some people will get worried about getting too focused on security because you think it's going to make your job harder. But you don't want your job to be too hard. People need to recognize that because otherwise you can't actually respond when security threats happen. Another one is coding standards. Just, really the OWASP list is kind of your go-to. If you're just looking for a baseline of what is my new coding standards, the top 10 things I had on the previous slide, it's a checklist. Just use it. And then static analysis, you can actually go out and buy tools, or you can get the free ones. I think you said there were, what, 50, 52? There's a lot to choose from. And they're not silver bullets, but it's, I think, better than not using them at all. Thanks for bearing with me on that agility thing. All right, so anyway, at a certain point, you get to the company level questions. You can analyze this as much as you want from the technical side of it, but if you don't win over the people who are making the decisions, unfortunately, there's not going to be any change. And there may be some legitimate reasons for why people aren't jumping into it. So I think it's good to think about this. And you're going to have to raise these eventually with the director of engineering. You're going to have to raise it with the CTO if you really want traction. So the first thing is just you got to put a price tag. You got to value the risk. The people who make the decisions, they want to know how much is it going to cost me if I have a security incident. If it's not much, then they don't, they'll say I don't care. And the second thing is the budget. How much are they willing to spend on it? And a lot of this is just about how seriously do they take it. And if they don't take it seriously, then you're going to have a short conversation, and none of this is going to go anywhere. But if they are willing to budget, the next step forward is organization. How you structure your workforce to get the job done. Who's going to do it? Do you have to hire new people? Do people's job descriptions change? And if you get past that, then you're ready to talk about policy and compliance, which sounds terrible, but really it's all about the technical stuff. It's like the architecture, it's the vulnerability response, it's the coding standards, and static analysis. How are you going to go about it? And the people at the management level, they don't need to be weighed down with the details, but they do need to see that you have a process that people are going to follow to set policy, to figure out how you'll get compliance. So I'm going to leave you with an uplifting quote from this security researcher who says that most organizations, they grow their security maturity the hard way. They get hurt. And maybe this is the way it has to be. I don't know. But I think just as time goes on, we're going to all want to know way more. And that's all I have. So thank you very much, everybody.